I'm ready when you are. Hello, welcome back. I'd like to introduce Themba Ngobeni from CSG International. Themba is an information and cybersecurity enthusiast with 16 years of cross-cutting industry ICT experience within sectors such as telecommunications, oil and gas, retail and transportation, banking, higher education, and national, provincial, and local government. He holds a master's in information and communication technology, summa cum laude, with a focus on quantum teleportation security infrastructures. Themba has occupied various roles such as CTO, CIO, CISO, project engineer, managing director, EA, ESA, technical program manager, solutions architect, and data warehouse, and BI architect, which I don't know what that is. He'll have to tell us. On projects which won international accolades and considered first in their areas to achieve such in South Africa. Welcome, Themba. I'll turn it over to you now.
Thank you very much. And good afternoon, ladies and gentlemen. Thank you for the organizers to invite me to come and present the state of my mind. So, as they said, my name is Themba Ngobeni. I'm currently an architect for CSG International, and also I'm a PhD student at Cape Peninsula University of Technology. So with that, today I'll be talking about machine learning and learning model for big data privacy protection. So this is still a work in progress as I'm running it in parallel with another project that looks at signaling security for telecommunication networks on 5G. But in this case, I'll just be focusing on machine learning and learning models for big data privacy protection. So my focus, it will be on the telecommunications with regards to interconnect and roaming networks. So as to the background, we know that machine learning has got lots of algorithms, but when they're combined with big data, it enables the telecommunication sector to evolve their data into actionable insight. From there, they're able to detect, they're able to classify, predict, recognize patterns, and apply self-learning techniques. So we know that in the machine learning, that different types of algorithms, techniques, and different type of, I can call it approaches. So currently the telecommunication industry is actually sitting on a big data gold mine. This actually provides them with a unique strategic advantage to improve the core business performance. The big data side enables the telecommunication industry to capture, analyze, and monetize enormous volumes of subscriber information. Others, they call it customer information, and data interaction across multiple touch points. In this case, one of the touch points I'm going to focus on is the interconnect and roaming networks, but with regards to the big data and machine learning. So what is the issue with that? Actually, we can't really call it an issue. We can say there are shortcomings in the machine learning techniques, which involves the data privacy, data poisoning, and an issue when it comes to generalizing knowledge. Machine learning is very good when it comes to pattern recognition, classifications, detection, and prediction. However, when it comes to the generalization of knowledge, it still has got some issues where it still needs to learn a little bit. And at the same time, there's a lack of interpretability and explainability. What do I mean about lack of interpretability and explainability is that some of the machine learnings where it applies self-learning, it can create its own type of behavior and does things in a way that other people or even the creators of that algorithm doesn't understand what the actual machine is actually doing, but they're able to see the results. So based on that, you're not sure that whatever knowledge it is displayed, is it fair, is it non-discriminatory, and is it safe for use? So that's one of the actual things. And then we look at the telecommunication mobile overview with regards to roaming. I decided to focus mainly on 5G, the 5th generation, because it's one of the latest generations of our time that has already created a paradigm shift across the overall communication service providers and the mobile network operators, mobile virtual network operators, and the likes. So in this case, I'm going to start looking from the area of 5G user equipment, where we've got multiple scenarios that we can look at. Let me start from the 5G NR. NR actually stands for the new radio. The new radio communicate through the core network. So the core network for 5G is called the 5G core. So that 5G core, normally when it does interconnect and roaming, it goes through something called either the IPX, or it can go through normal direct connection. But in terms of moving across different countries, overseas and all that, you might need to go through different layers of IPX. It's an interconnect network. So based on that, we've got the new protocol that runs that area for the interconnect and roaming that is called the HTTP2. So HTTP2 is part of the non-standalone and the standalone scenario of 5G. And coming down, we look at LTE. LTE is a long-term evolution. The long-term evolution is actually part of the 4G, the 4th generation networks. So the core network of the 4G LTE is called the EPC. EPC is actually the enhanced packet core network that uses something called the DES for the phase 2, 5G non-standalone, and then the LTE scenarios. One of the areas within the interconnect and roaming that it actually uses is called the diameter. It's part of it's called diameter. Diameter is used for the intercommunication between the two areas. However, if it needs to downgrade, it moves down to something called GTP. The GTP, it's actually the it's the GPRS transmission protocol network that is used for the lower technologies that I'm going to get down to right now. That is called the 2G and 3G. 2G is the 2nd generation network, and then 3G is the 3rd generation network. So if you look at the overall 2G, 3G, the LTE, and the NR, new radio, it all forms part of the radio access network. So from the 2G side, it communicates with something called circuit switching network. So you've got circuit switching networks and you've got the packet switching network. That's why we've got in this area is called the CS and PS. So that's circuit switching and the packet switching. So this is one of the areas that also I'm going to come down to. However, when you look at it, they're all within the core network. They've got something called the VPMN. So this one is a visitors public mobile network. In the latest instances, they normally refer to it as a visitors public land mobile network. So it will be a VPLMN. And then while on the other side, we've got HPMN, that is the home public mobile network. So now coming down to the other level of the 2G and 3G. 2G and 3G is considered the unsafe, or it's less safe compared to diameter and the 5G. However, that's a debate for another day. We know that actually it has introduced more vulnerabilities in the network compared to the SS7 and the GTP network for the 2G and 3G, but we'll talk about that maybe at a later stage. So what happens in 2G and 3G? The interconnect and roaming network connects through a protocol, a signaling protocol called the signaling system number 7. So it's the one that allows that infrastructure for people to move across different countries and still be able to enjoy the same access to services from their home network. So the SS7 infrastructure is one of the biggest so far in the world, and has got a stable infrastructure that has been built, which has got plus or minus 800 types of mobile network operators. Okay, so now we'll come back to the motivation. What motivated me to look at something like this? The reason I had to look at machine learning for big data in the interconnect and roaming network, it was one, looking at the data privacy regulation. So the data privacy regulation, we've got areas like Data Protection Act that is used around South Africa, as well as POPI, that's the privacy of personal information, is still around South Africa. And then we've got the General Data Protection Act that is the standard across Europe. And yeah, there's still other ones that still play a role. So what did this privacy regulation came up with that makes us to start looking at this type of machine learning and learning? Number one, they introduced the right to be forgotten and the right to object. So the right to be forgotten has created a panic that created another field in the world of machine learning, because if a data owner decides that the data that they had, it must be deleted or it must be removed, it must not be used anymore, the machine must be able to forget about it. And then the cost of the machine to go and relearn, it might take more resources and can have more things to be done compared to having the machine after the post learning to just unlearn. Another thing is the right to access and the right of rectification. So a person can be able to go and rectify their information if they feel maybe is discriminatory or it's not correct or it's already outdated. So all of that is part of the data privacy regulation. And if you don't do that, normally there are fines that are associated with it that can actually cost the companies a lot. So when it comes to telecommunications, this can be a serious amount that the telecoms world can actually lose due to these regulation violations. And then we look at machine learning models. They are usually trained on sensitive personal data, which can violate the HIPAA, the POPI Act, and others. So those, they normally look at, especially for the HIPAA and the HPC, the one that looks at patient health and the doctor's consent and the rest. It looks at disease diagnosis, the facial recognition, and then keyboard input predictions and on mobile devices. So based on those things, the specific information that you don't really have to allow, if the machine is already learned and the data owner decide that it needs to be removed, you must be able to do that. So other bigger companies like your Google, Facebook, and other social networks, they decided to come up with other forms and other things that allows a data owner to go and apply for their data to be actually unlearned or to be removed from the system. So the right to be forgotten, as previously explained, and encountering data poisoning attacks as calls for machine unlearning field. So that's where the field actually started to come up, because we've got the right to be forgotten, and we know that they're still countering data poisoning attacks into the machine learning world. So removing or unlearning specific machine learning trained data causes model updates, which in other cases is susceptible to information leakages. So the information leakages is not only on ML trained data models. Even the machine learning and learning field actually is the one that causes some of those information leakages. But we need to come up with ways in which we can re-strategize and come up with other techniques and approaches that will make it more secure. And then what is the aim of this study? So the aim of my study was to investigate the effects of machine unlearning techniques for the big data ecosystem in order to protect privacy of information in the interconnect and the roaming networks. So what were my objectives? It was to investigate and determine existing machine learning privacy limitations, to determine the appropriate machine unlearning techniques to apply in the interconnect and roaming networks, to develop privacy protected models as an artifact and actually a method, and to evaluate the machine learning unlearning model and method with simulated experiment. What am I trying to talk about here is because when you look at the interconnect and roaming networks, it will be creating such a huge amount, or let's say enormous amount of data. Companies as Positive Technologies, companies such as iBasis, they came up with a prediction that by 2024, there'll be 475 plus in percentage grow in roaming data movements. So with that, we need to make sure that whatever data that moves around based on the information that we're going to learn through the big data, applying machine learning is going to be safe in enhancing the interconnect and roaming network. And what am I going to do around that? There'll be a development of a model as an artifact and also a method as type of a protocol that can be used. And later on, we're just going to do the evaluation to make sure that whatever model and the methods that have been created through the simulated experiment of the telecoms environment, it can be effective and can be efficient. Okay, so what are my research questions? My research question, the main one, it says, how can a privacy protection machine unlearning model be developed to enhance interconnect and roaming networks in the big data ecosystems? So with that, we've got sub questions that we need to go through so that we can be able to answer the main question. That is, what are the machine learning privacy limitations? So already we need to go through in order to determine what are the limitations, because there might be more limitations more than what we might be currently aware of. What are the characteristics of specific machine unlearning techniques? When applied for interconnect and roaming networks, it will improve privacy. And what are the design considerations for machine learning and big data privacy protection? So with these questions, one is like, we're going to determine something. Number two, we're going to also determine and look at other different areas. How do they work? What are the characteristics? What are the different scenarios that work better on a specific scenario? Based on that, we're going to go and develop. So when we have to develop, we'll talk about what are the design considerations. What do we need to look at when we design and develop such a model for machine learning for big data privacy protection? And how efficient and effective is the ML model for enhanced privacy protection? Based on that, we need to look at how well does the model actually work? So how usable will it be once it has been created in enhancing the privacy protection? Then we looked at the literature review, just quick one that I had to focus on. One, it was that most of the researchers, they talk about machine learning models that they can create their own behaviors and decisions in ways that their own creators can't understand what's actually happening. And then it makes it more difficult to resolve issues and ensure that information that has been produced is accurate, non-discriminatory, and it's fair. And then also there's a lack of explainability and interpretability that I already spoke about when we started. And then it's known as the black box problem. And then the other ones that the developers normally face, it's called the algorithm fatigue. And then now on the last one, you say the right to be forgotten and countering data positioning attacks call for efficient techniques that can remove or unlearn specific training data from the trained models. So that's where it actually gained more from the research community, so that it created that view that, you know what, there is a field that we need to start looking at that talks about this type of machine learning, where we need to start protecting the rights of others. And then what is the research process that I'm going to follow? I'm not going to go through the overall research because I know there are multiple things that happens within the research world where I need to talk about my paradigm or my philosophy that will be coming from the pragmatic side of things. But yeah, what I'm going to look at is just the design science research process that has been created by, originally it was by Hevner, and then later it was applied by Vaishnavi and Koeltler around 2004. So this looks at the knowledge flows, the process steps, and the actual outputs. And it starts with the awareness of the problem. What is the problem? How did we get aware of the problem? So we say we got to understand about the problem when the Data Protection Act came, and then it was starting to be enforced and talk about people have got the right to be forgotten, or the data owner has got a right to be forgotten or to remove or delete information. So based on that, the output of the awareness of the problem normally becomes a proposal of what I'm hoping to achieve. So I need to propose on what I want to do. And then there's a suggestion. On the suggestion phase, that's where we come up with different literature information. That might come from the design science has got multiple paradigms that we can look at. It can be both from the behavioral science and can be coming from the physics side of things, or I will just call it the science is coming from the science side of things, physical science and computer security and computer science, things like that. And how, when we look at it, will it be able to solve this information so that it can be useful to the community at large? So because the design science needs to go and contribute an artifact that will come with the level of truth and also a utility. So we need to bring in two different types of paradigms that looks at both the truth and the utility. So that's why we spoke about the efficiency and the effectiveness on the other side, on the previous slide. Based on that, we go and look at the development, where we develop or we design the actual artifact, and we start developing the overall algorithms and the models. So based on that, from the development side, there is a circumscription phase that will go back, because the more we start developing, that's when we learn and when we become aware of new problems, or we start gaining more knowledge, where it might trigger another suggestion phase that will lead to more information. Then we're able to start developing. So the more we develop, and then when we finish, we're able to create an artifact. From the artifact, we go down to evaluation, where we need to evaluate our model and our artifact based on telecommunications scenarios with regards to the big data area. So based on that, there's still another circumscription phase that will go back and lead us into the awareness, suggestion, and then more development. And then once we have finished all of that, then we can already look at the evaluation stage, where there are multiple evaluation stages that happens. There are other ones that focuses on simulated experiment, that is part of experimental type of evaluation. And then there are multiple ones where they can be like the prescriptive knowledge, there can be descriptive knowledge, and all that. So based on that, we've got performance measures that we're going to use in order to evaluate that model. So the world of machine learning has got lots of algorithms. Some are already standardized that you can use as a performance measurement technique. After that, we go over to the conclusion. The conclusion, that's where we're going to get to produce the output that will be the results of our overall structure of our overall research. So with that, there is a contribution to knowledge, design science knowledge. So based on that, when we contribute into knowledge, it might going to go and trigger other people to go and explore more, or maybe able to go and create more other things on top of what we have already learned. And with that, we create the results, and we make sure that, since it will be, I might be looking at more of an open source type of scenarios, we need to make sure that the open source community also benefits from that, where we need to make sure that the results is already put out there, and other people can be able to take that data source that I've used with the overall development stages, the evaluation metrics, and be able to use it, replicate and reproduce what I've done. And then they'll be able to take it from there in order to enhance the knowledge and also contribute back into the community for the overall society. So I've got more references. There's more than this, but so far these are the main ones that I felt that the ones that I had to consult the most, but there's still more that we can actually look at. So with that, thank you very much. And thank you to the organizers for allowing me to come and share what I actually had. So with that, if there are any questions, please feel free.
Thank you, Themba. We have
Thank you.
questions from the field. Hearing no questions, shall we move on?
Can I ask a question first?
Please.
Great.
Yeah, this is Stig. Thank you, Themba. That's really interesting. I've not heard this term data poisoning before. Could you give an example of what it is and what result it achieves?
The data poisoning, it's just look at it from for a clear example, from a specific malware that gets inserted into a specific data. So when you go and access that data, it executes its own type of it's what can you call it, like, you know, an adversary. When an adversary comes in, they're able to go and do whatever they wanted to do because they've already opened a specific, let's say, an attachment with information that they've already, or code that has already been created. So what happens with the data poisoning? Once you learn something in your data set, we can go and start plugging in something in your data set that goes together with whatever you are doing. But the more you start running across different levels, we're able to go and get the information. So let's say you had to unlearn something. On our side, we've already got that information that you've already unlearned, because once you have got data in use, I think in terms of security, you know, we've got the CIA, confidentiality, accessibility, and accessibility. So based on that, you've got data that can be in motion, data that is at rest, and the data in use. So normally we do the poisoning on the data in use so that we can be able to see all the different stuff that normally happens.
Very interesting. Thank you. Are there any other
Thank you very much.
No? Well, at this time, I'd like to introduce Stig Telfer. Stig is with Stack HPC. Throughout his career, Stig has worked in R&D at leading HPC companies such as Mako, Quadrix, Cray, and Alpha Processor. Am I pronouncing that correctly, Mako?
Yep, that's good.
Stig worked in networking silicon development, embedded machine vision and AI, software-defined networking, and OpenStack for HPC infrastructure management. He is CTO and co-founder of Stack HPC and continues to work on the convergence of cloud, HPC, and big data. He is co-chair of the OpenStack Scientific Special Interest Group, a globally distributed grouping of research institutions that use OpenStack for research computing use cases. And I believe Stig is based in the UK, is that correct?
That's correct.
Very good. Well, welcome. Thank you for joining.
Thank you very much. Yeah, thank you for having me, everyone. So as Elizabeth says, I work for a company called Stack HPC, and we're a small business, fairly specialist. You probably won't have heard of us unless you are also working in the sort of the sector of open source, sort of open access cloud infrastructure. So as you just heard, the journey to this point has been quite a long and interesting one. I've been very fortunate to work in a lot of really interesting technology companies, and really moving from system design, silicon design, networking, and now down to how to apply open source cloud infrastructure to making machines for high performance computing and for research computing in general. A lot of the work that we do is to enable companies that have, or institutions that have, sensitive data sets to enable them to work with those data sets using a cloud native methodology. So by that, what we're talking about is how do they make a software defined infrastructure without sacrificing any concerns about how do they retain control of their data and where it resides and who has access to it. Now, it is a very nebulous thing. And so there's an interesting categorization done in the UK where they tried to look at how different approaches for cloud and managing sensitive data sets. And they produced these 5 categorizations here about the level of security and the level of data sensitivity that a cloud infrastructure might be implemented to. And in most cases, in research computing environments, we look at tier 0 or tier 1, in which case there may be the sort of consequences of data loss or data disclosure might only be that someone else gets your research data and they might get to access it before you've published anything about it. That gets more interesting, though, when we start to look at institutions that might be doing, for example, medical informatics or bioinformatics, gene sequencing, and other things like that, or companies that are working with highly sensitive trade secret data. And then we start to go up into sort of the tier 2, tier 3 environments, where we start to look at these fairly sort of isolated and walled off systems where the data that they're processing can be extremely sensitive, and they really want to apply all of the levels of protection that they need to in order to ensure that the integrity of that system is justified. When we look at cloud infrastructure, one of the interesting pieces about it is that machines are made by automation, and so they're not really hand built, and they're not really built in a sort of a manual process. They're usually built by a script, a playbook, another software machine, and so this can actually introduce cutting of corners, relaxation of attention on what happens with the machines that we're building inside the cloud. And there's a very interesting paper which I do recommend to you if you're interested in the field of security in cloud environments, which is this one from the NSA Cybersecurity Center. And they characterize these 4 classes of attack and vulnerabilities within systems, and they gave some very nice examples of each of those. And the point they wanted to make was that there are attackers who might want to access for example, in this case, an Asus tablet, and they wanted to access a specific tablet owned by a specific person, by a set of people. The effort they went to was extraordinary, and I think most people would be unable to defend against it. We can go to sort of slightly more accessible kind of attackers where we talk about things that actually might affect institutions and companies who are running cloud infrastructure of their own. And for example, what we might see is there were some nice demonstrations of how a virtual machine can break out of a VMware hypervisor. And in fact, there's examples for any other type of hypervisor as well. So these start to get, I mean, they're difficult breakouts to execute. And once you're in the realm of the hypervisor, it might be difficult to do anything more. But it is possible and can be done by a determined attacker once they are on a system. But those are rare, they're few and far between. And actually, the things that the users of cloud infrastructure do or don't do simply to secure their systems are far easier ways in than any of these other kind of looking at supply chain, so looking at the hardware and firmware, or looking at the software running within our hypervisors. People can just make it easy for you to crack their passwords, or not even set like anything beyond a default password on an account. Misconfiguration of instances running in cloud infrastructure is the easiest and most prevalent attack that anyone can do. And there are some very good examples where hotel chains, in this example, were putting their data behind an Elasticsearch database or a MongoDB database, and actually not really bothering to secure it so that you could see which hotel room a guest was in which hotel. And that was just, you know, an obvious and very easy way to access and compromise systems. So when we start to think about cloud security, we have to take it in context that there is some real low-hanging fruit that is probably where the majority of our focus should be. The rest of this talk is really focused around the sort of the middle region here. So consider the low-hanging fruit. Let's hope that that's been dealt with, and we'll come on to what do we do about securing our cloud infrastructure itself. So the business that we work in is mostly around deploying OpenStack infrastructure on site for research institutions, and this is a popular model in order to enable flexible research computing while retaining control of the infrastructure itself. To make this work really well and to provide a system and a service that has a strong integrity to it, we often have to look at the human processes that we have within our teams. And these are probably the most important aspect of operating your own infrastructure, is to have these procedures and you know, the right methodologies, the right runbooks when things go wrong, in order that we know what we need to do in order to analyze, communicate, rectify, and so on, and prevent it from happening again. I got a nice example here actually of an email we received a couple of years ago, obviously a phishing attack. That the people happened to know two of our employees, our CEO, John Taylor, and our financial controller, Sarah, and created this crafted email. And possibly by luck, but you never know, they even managed to characterize John's occasional penchant for extraneous hyphenations and capitalizations. And the wording of this email could easily have come from him. But we noticed that it's not from him at all. It's from some dodgy phishing people trying to set up a payment to extract money. So we need to have the human processes in order to be able to identify and respond to these things as well. But from the machine's perspective, so drilling down a little bit further, we also can do a lot down at the layer of the infrastructure itself in order to manage the security and the integrity of the service that we are providing. And really this boils down to having what's called an SIEM system, Security Information and Event Management. And this is a very helpful platform to have within your infrastructure in order to monitor the goings on and any unusual activities across the rest of your system, and to flag up and alert and help you to maintain a reliable and safe system for the users of the system. So SIEM includes these components. We need to be able to observe, as in monitoring, our using agents running on our infrastructure. We need to be able to identify using a pattern matching or a characterization, which is where AI could come in, to identify unusual events going on within the information stream of normal operation. We need to be able to extract that data and make it available somewhere off host, so that if the host is about to get into trouble, the data about the path in is preserved by transferring it off the host and onto another place. We also want to be able to ensure that the machines that we have deployed are deployed to some definition of best practice. And usually that means compliance with a well-known security standard. finally, if all of this doesn't work and everything goes wrong and we get a security breach on the system, which these are only mitigations for, they don't actually guarantee it won't happen. We need to be able to build up the trail to do the forensic analysis to understand how did that happen in order to prevent it from happening again. So in Stack HPC, we have been working for the last year or two in developing a way of monitoring the infrastructure that we deploy for clients. And we're coming out of a sort of an R&D phase, and we've been using this open source platform called Wazuh, which does a lot of useful things in order to manage SIEM, Security Information and Event Management. And it helps us to provide the monitoring that we need in order to be assured that the service we provide is safe and secure. So it runs by adding agents onto all of our systems. And if I just go back one, it provides these capabilities. So it has its own expert rules in order to understand where unusual things are happening, anomalous things, not your everyday kind of events. So it can actually help us to detect when an account is being compromised or there is being an attempt made to break into our system. It can also tell if a break-in has happened, whether things have changed on our machines, and it can tell us if there are open doorways, vulnerabilities, known flaws within the software that is running on our environment. And so it can warn us to say, this is a CVE, this is a vulnerability, you should patch this. It can tell us whether our host operating system configuration, the configuration of our private cloud hosts is wise, whether it has all of the right measures in place in order to make it as secure as possible. And therefore it can tell us about whether we implement particular standards that we might have. Themba was talking about HIPAA, for example. So we might say that if in order to have a system which is certified for being adequate for processing data that is HIPAA, then we need to be able to say, well, this thing will help us say, yes, we are doing everything that we need to do in order to process that kind of data. It's the nice thing about Wazuh is, and one of the reasons why we chose it is it's open source. So it's based on OSSEC, which is an open source project, and you can download it for free and install it yourself, and it runs on most of the sort of widely available Linux distributions, plus Windows and Mac OS as well. It's open source, but Wazuh is a company, they're a business, and they will sell training on how to make the most of the system, and a commercial customer support package as well. So that's the business model. It seems like quite a good one because they make available their system for public scrutiny, and we can add things to it if we want to and contribute them back to the project as a whole. So we are, in our company, we're very much in favor of the open source model as a way of doing things, and it's nice to see a fellow traveler with similar beliefs. The interesting thing, I know that we were talking about using AI in security. This is more of a sort of an earlier generation model of a sort of AI, or not really AI, but it's more of an expert system. So it has a elaborate set of classification rules and so on for different types of behavior. And we can see some examples of those in a minute. Just to be clear, when we're talking about the security monitoring of cloud infrastructure, we're not talking about the things that are running inside our cloud, as in the things that the users are making, the compute VMs, the storage resources, or the networks that they're creating. That's not really what we're talking about here. But I know that we have customers or clients within our customer base who are doing this using Wazuh. So they will deploy platforms and deploy Wazuh within them. What we're looking at is the hardware that manages our control plane. So switches, controllers, storage, hypervisors. Those things themselves implement the cloud infrastructure, but they are deployed and managed and operated using a separate set of resource, which is usually an admin node, sometimes more than one. And it's there that we run our Wazuh manager, which is the master process for observing and controlling and interacting with the security monitoring. We run agents within the hosts within our control plane, so not within the VMs, but within the hypervisors that run the VMs. So this is the position. And so what we're monitoring really is the hardware, the host operating systems of our control plane, rather than the guests and the virtual machines and the workloads running within our cloud. Okay. It's actually fairly easy to set up and deploy a Wazuh environment. It runs on CentOS, Red Hat, Ubuntu, and the resources it requires are generally not too big. It consumes information, event streams from the hosts of the control plane, but in a sort of a typical deployment, the events generated in that stream are not, a very high volume. So the resource requirements of Elasticsearch are not massive. The way that we deploy it is to use Ansible playbooks, and we combine those with the inventory of our control plane itself, which is itself deployed as an Ansible environment using the tooling that we use called KUB. The combination of these things creates an infrastructure as code environment where, with one source repository, which is version controlled and audited, we're able to deploy our OpenStack environment and the security monitoring that looks after it as well. When Wazuh is running, it's going to be consuming data from various event or data sources within the host operating system. And it looks for interesting things according to its rules, its expert system data, pattern matching. And we can see that it starts to send off items of interest back to the Wazuh manager. And those are then stored as JSON documents in our Elasticsearch. And so we can see 3 examples here of things that the agent thought were interesting to mention and has escalated off the host onto the Wazuh manager. These are documents as presented by Kibana, the graphical user interface of Elasticsearch. But actually, it's a little bit more user-friendly. We don't have to worry about reading those kinds of events and making sense of it ourselves, because one of the really nice things about using this environment is that it can also generate graphical depictions. So we get these nice sort of data plots of the things that might be happening on our machine. And also, if there is something that is sufficiently interesting, we can get it to emit an alert. So in our standard methods and the way that we usually work with customers, we might have a Slack channel where we can post alerts and monitoring events and other things. And Wazuh can generate alerts alongside any other monitoring infrastructure, so that we get a little message pop up in the instant messaging, which says, something's just happened. You might be interested to know this. And so then we can respond in real time if it is an unfolding event that is important. There's a very significant thing that we need to be aware of, though, which is that generally it's a little bit Chicken Little and tends to run around saying the sky is falling in when actually someone's just logged in and run a playbook. And so it's very important to tune the threshold of the alerts that we get to avoid getting bored and fatigued by them, and then basically ignoring them, so that when something really does happen, We don't notice it because we're no longer watching, because there's too many of them to pay attention to. So setting the right threshold of what is significant and what is not significant in the host systems of an OpenStack control plane is a really important thing to be able to do. Another nice thing that Wazoo provides is an assessment of our configuration. So it will say, you implement this standard for security infrastructure. And it produces a nice document. So when we say our machine is only 50% compliant or something, it will say, these are all the things that you have not done. In order to be compliant, you would need to do this in order to fix it. And so it has a very helpful set of examples and explanations for why a host operating system is not compliant with a specific standard. Another part of this is to say your machine does not implement or has not installed the latest packages and is therefore vulnerable to some CVEs, some published vulnerabilities. And so being able to keep on top of these things with frequent package updates is one way that Wazoo can say to us, you are still vulnerable to some critical vulnerabilities. You need to do something about this now. So I realize we're a little bit over time, but I guess that I wanted to give you some nice examples of what can be done using systems or platforms such as Wazoo to monitor our cloud infrastructure. This could be extended to monitoring the things that our workloads, our guests are doing on the system as well. And given that that is where the low-hanging fruit is in our security, it seems like a strongly advisable thing to do, to take an interested eye in what the users of our machines, our clouds, are actually up to. Wazoo is free. It's fairly easy to use. It seems to be very capable. It does all of the things that we would expect a SIEM system to provide for us. But in the specific realm of cloud infrastructure, it is a sort of a sealed box, a fixed appliance with one function. And I think from my perspective, CTO in Stack HPC, I'd like to develop it or develop how it works in our systems a little bit further so that we can start to observe what it thinks about the health of the OpenStack services that are running in our machine, and also being able to understand the containers that are running the OpenStack services themselves, and generally just to make it work a little bit better for us. So I apologize if I've kept you over. I think that was all I had to cover. Thank you.
Thank you, Stig. Do you have any questions from the field? Nishak?
Thank you very much, Stig, for such a wonderful and informative presentation. So yes, we used Wazuhs in some of our HPC systems. So I just want to know if the possibility that we can use Wazuhs maybe as a central monitoring, like for instance, let's say we have another region in another place or another region in another country. Can we use it as a central a method of monitoring all those regions together?
What I don't know is whether there is particular sensitivity to different versions of the platform talking to each other. So let's say that we had the Wazoo agents on one machine talking to a Wazoo manager that was deployed somewhere else. I don't know how sensitive it is to running different versions of the software, because they might get updated at different times. That's not something we've explored. I mean, I think it would be, I understand, I can see how useful it would be to have all of the security management in one place. So it's a worthwhile thing to push for. We haven't done it ourselves yet.
Thank you very much, Stig. And it has been a pleasure to have you here in this platform. And thank you very much for your support.
It's been, I've really enjoyed it. So thanks very much.
I think we're going to see you again next year. Yes. Over to you, Elizabeth.
Well, thank you, Stig. I think that concludes our presentations today. I see that there are no other questions coming in from the other platform. So I know I'd like to learn more about PCI and Wazoo. That could be a whole session in itself.
Yes, yes. We've been doing R&D with it and understanding what it's capable of. And thankfully, I mean, be careful what you wish for. We've never had to use it in a real situation. So we've never seen that side of it. But it's been really useful just to enable us to implement better compliance with security standards. What you get out of the box with a Linux distribution turns out to be quite far from that in terms of the things that they would like to see in standards like PCI.
Always changing. Well, thank you so much.